jet engine, you want to get the bigger the turbine area, the better. The bigger it is, the better on the turbine section. You look right here on the turbine section. You know how you could tell? Just get yourself a ruler of some sort, and you want to get in there as best as you can. You want to make a close judgment. You know, like I'm using millimeters right now, but you could see. Okay, now it's about 85, somewhere in that range. You want to keep that 85 right here. Look where I'm moving it. Okay, whatever, 83. You want to turn it around. Now go over here on your compressor section. Make sure that it's smaller, so you're bringing it down. Okay, good. This one's showing 69. Okay, so your turbine blade's bigger, so this will work. This will do. Now, if you have a turbo like this guy right here, it's really small. You don't want to get too small because you know they won't run as well. It depends on your combustor design and it just really depends how you design it. Because if you want something that's gonna run really good, get a bigger turbo. You know, or get. I mean, this is probably as small as you would really want to go. This one right here has a. I know it's slightly over 2 inches, so it's like 2.37. Okay, and you look over here to your turbine section, which you want to check the exducer area, which is right here, and that is reading 2.49. Okay, so that's better. I mean, that's better than having a smaller turbine. You want to have the exducer a little bit bigger than your compressor blade. If you look right here in your compressor blade, you know how you hear the term compressor section, exducer, inducer. This right here is your inducer section. Inducer means your flow's going in right here. That means your inducer section is right here, so your measurements from here, between here to here. Turbine exducer, inducer section would be right here, because your flow is coming through on these blades right here where it's got these curve sections right here on the blades. That's your inducer section on your turbine blade. So that's your measurement right here if you wanted to measure the inducer section of your turbine blade, which is the very far outer edge. It's 2.89. This is your exducer section, because that's where your exhaust flow comes out. So that's 2.50. Here's just something very close, you know, to what you would want to get. You know, you just get your turbo. It's not perfect. Like, you just take this out right here. This is your flame tube, and combustor dimensions are already done for you right here. This is your flame tube, which is from right here to here, which I'm going to show you. You know, this is just a rough guess. I mean, if you want to know. This is your flame tube, okay? This is how you get your outer combustor casing diameter, where I'm pointing with the caliper. Just right on the edges. From right there to here. Gas right there. From right here to right here, and your flame tube right here to right here. You just want to know, you just take your compressor housing off, and then you flip it around, and you look at this, and then you go over here to here. You know, and then if you want to get your length on your flame tube, you just think about it, you times that by 3. Go 1, 2, 3 to whatever dimensions is showing right here on your flame, on the diameter section. You want to times that by 3. So what do you say? You go right here, let's just say, okay, that's 5 inches, okay? 5 inches, you times that by 3. So it's like 5, 10, and 15. That's your length right here on your flame tube. So you got your diameter, which is 5 inches, and the length between, okay, that'll be 15 inches long. It's a very rough guess, you know. I just want to help you guys out if you have any problems with measuring. You know, you don't know what size combustor you want to make, or your flame tube. That's just a really good rough guess right there. You know, it would work. It just depends on how you do your holes. You know, like you want a measure out your holes. You're just experimenting. You know, you want your primary section to be smaller, in secondary section you want to have a little bit bigger, and your dilution area you want bigger than your secondary section. So you would want to, like, you know, just an example, like your first section would be like 1/4, and that's your primary section. Your secondary section would be like right 3/8 or so, and then your dilution area would be like, I don't know, like 5/8 or so, you know, something around there. Yeah, so it's just an example. I'm not telling you that's what your holes should be. Also, before you get a turbo, you want to really pay attention and go over here, grab this nut right here, and if you can, go on the other side with your other hand to your turbine nut. You want to try to see if it's wiggling. You don't want too much shaft play. You want to, what you want to do, how you can find out if it's good or not, you push as far off to one side as you can, and turn it at the same time as you're putting pressure off one side. You want to turn it. If it's scraping right here or anywhere, then don't get it. Or you can also look as well on the sides in here, and you want to pay attention and notice if there's any scratches on the sides of the walls, and make sure there's no corrosive or chipped blades at all on this when you get one. I got this from a salvage yard, like a Ecology. That's exactly where I got it at, and they sell between $100 or $150. But most of them, they're cracked and broken, and they're very hard to find them in good shape. So if you can, go on eBay, because you're guaranteed to get something that's going to be all right with you. You know, if you want to spend all day trying to examine these turbos when you're going to a scrapyard or a junkyard for big trucks, you're gonna be there for a while. Because I was there for about 4 hours trying to get the right turbo. And just look at the turbine blades to make sure that they're not chipped. If you can, bring a little small flashlight, and you want to shine inside right here and examine the outer section, which is the inducer section of the turbine blade. You want to make sure that there's no chip sections, one by one by one. You want to just see that, and just notice that when you turn it, it's not really stuck. If it's really stuck, don't get it, because those you don't want to gamble on the ball bearings. If it spins at all and it's kind of hard to spin, it's okay. You want to just get a cup of oil, heat it up for like 20 seconds or something in the microwave, and spin the blades with a leaf blower. You want to put your leaf blower here, and it'll start to spin really fast as it can with the leaf blower, and it'll soak the ball bearings in oil and let it just sit for another day. You notice that there's no center divider right here like this one has. See that? And some turbos have them, some of them don't. Either way, it doesn't matter. I mean, if you have one, if you're going to get one and it has a center divider that's split in the center, you want to take a grinder or some sort of a disc cutter or some, and then you want to kind of grind down this area to make it aerodynamic, so the exhaust flows through very quickly and easy.